Yeah, another draft physics video presentation and such. Mostly. Yeah. Alright, so anyway, comments mostly, I think, and then some Sean Carroll, maybe if there's time, and whatnot. I think we're going to talk about redshift a little, and the basics of, always something, the energy equivalency, the assumption that every part of the universe obeys the same rules. That you can use this word particle to describe everything in the universe, and that the same F equals ma kind of rules apply. And I would argue that the subtlety is a little more complicated, that the fundamental kinetics don't necessarily obey those rules. So it sort of gets to how photons function, how energy gets through the universe, the whole the perfect reflection can look just like the perfect miss, theoretically. Anyway, depending on how you measure time, even. So anyway, we'll get to that. You're banging your head against a brick wall in regards to Pyrrho. You can't educate pork, Gary. Whatever. It's really not the point. The point is this real human dilemma. There's facts in the world, and there really shouldn't be the range of possible mixture, right? It's kind of like cake recipe. You just can't make a cake, at a certain kind of ingredients, arsenic and dirt and, blah, blah, blah. It's not going to be cake. And somehow people mix the ingredients of the facts, and somehow we're allowed to make the facts into all kinds of silly conclusions. And frankly, I don't see how that's should be possible. It just shouldn't be possible to in a reasonable world, in a world where people are supposed to be reasonable. And I just argue that Pyrrho's an example of that, in that his interpretation, his view, is so scanted and biased that it just doesn't make any sense that he can have these conclusions in light of the evidence. And that's the part to try to understand. I mean, he seems to know how to walk a straight line, but he doesn't seem to be able to think one. I mean, obviously he gets through his life functionally. But you're saying, if he's so bad at processing information, why isn't he walking into trees? I mean, maybe he's had a lot of car accidents or something. Maybe he does stumble around and I just don't know it. There's a lack of consistency between people's everyday practical functioning knowledge and their philosophical perspective. Somehow there's no continuity between the logic they seem to be capable of applying to the real world and the logic they apply to thoughts regarding the structure of the world, the part they can't see. When it comes to seeing the part they can't see, they're really bad at it. And that's the part that's hard to understand, because they shouldn't have that much problem adding up these facts. It's like detectives showing up at a crime scene, and you just can't figure out how are those detectives drawing this insane conclusion, that, Polly Prissy Pants did it in the, laboratory with the hatchet or something. And you're saying there's just no facts that add up to that. That's just a silly conclusion. Why have they drawn that conclusion? It just doesn't make any sense. Anyway. Moving on. So this thing here, I don't care for the beginning of this at all. I suppose you don't deny whatever expansion of the universe. Why would you suppose I don't deny expansion of the universe? Now, what I don't deny is that there's something called redshift, okay, and that light from objects is coming to us shifted, changed, altered. That I don't deny. The idea of their explanation is the problem. I say there's lots of other places to look for reasoning why light changes over distance, besides their silly notions. Let's understand their silly notion, in my opinion. Now, we understand redshift in, Doppler shift with sound and other things, and that the shifting happens at the source. The source is moving. It means it's plopping something into the world at a different rate because it's moving into its own wave. It's catching up on its own wave, so it adds the wave sooner. And then when it's going away, the waves get further apart because it's running away from, the production. It's throwing the wave, then it moves further away, and then it throws the next wave at the frequency. Obviously, they're adding distance to the waves. So we see that it's something the source or the receiver does. It's not something that happens in space. Okay, so they're changing this equation of Doppler shift into something that has nothing to do with the source or the receiver. That somehow, in the process of traveling, okay, the wave expands because a bunch of extra space popped in there. Just magical extra space made things further apart. Now, I say that's an invisible man, desperately silly. What's the easiest and simplest and non-real solution to the problem? Oh, we'll just say extra space pops in. It seems desperately simpleton or something. Like you didn't think about it at all. I would argue that we know that space isn't empty space. As much as, it's a vacuum, it's not a perfect vacuum. And there is little bits of crap. And that little bits of crap could be scattering the photons just a little tiny bit all the time. And that little bit of scatter adds up to a little more distance. Okay, so the light's slowed down a little bit. It's a medium, like glass. Takes a little while to get through it. Okay, so it's a 0.0005 index or whatever. It's a very small index of refraction, but it's there. And, and through that process, the photon that was this is being turned into this, in the sense that one of the bits is being thrown out and a greater distance is being created between the photons. Now, I think that's a possible explanation, but there's a deeper one, more going, smaller physics, where you could also understand that this might be a possibility. So we sort of know something. We call these things quasars or whatever, these small bright galaxies. So we know the old galaxies are smaller and brighter. And so the big modern galaxies are bigger, and less bright. Okay. So this is the new, and that's on the board, right? Yeah. And this is the old. So when you're looking at something old, you're looking back at something that's different. And then I might argue the difference is that gravity itself, big G, was different back then. So you're moving through time. So the idea would be if gravity was different back then, you could sort of understand that the field that stuff had to go through was different. So if stuff is smaller, it means there was either it's maximized the pressure or it's expanding. So you could argue that the galaxies themselves are expanding. In a way, it's sort of obvious on galaxy level anyway. And that might be a byproduct of the fact that the field of gravity itself has gotten weaker. That is, as the matter consolidated, it consumed the energy in the universe, the pushing pressure, because more and more of the pushing pressure got trapped inside the objects. And then the reverse cycle starts to happen, where now these things expand, which means the pressure on the outside. See, it's always hard to figure out the curve of that thing, right? Because the two curves don't match. One curve is halfway behind the other curve. So as things get smaller, the field gets weaker, right? And as things get bigger, the field gets stronger. So the G is stronger now than it was then. And so the light that was sent at a frequency You could argue that if light is, these little bits of energy, and if we argue that the little bits of energy, see, the point is we could argue that the little bits of energy never hit each other, or we could argue that they hit each other all the time. Because the argument is if they do hit each other, they can only hit each other this way, straight on, because they're tiny. So they never have any crooked interactions. And all they can do is either, reflect off each other, or go through each other, right? Or miss each other. If they miss each other and they go through each other, all of the outcomes are the same. There's a bit going this way, and this way, and this way. So each one adds up to the same thing. They'd be indistinguishable. So you wouldn't be able to tell, theoretically, which one of these events was happening. Now, if we think that maybe time, that is, the speed of light, is actually dependent on this event. So the fact is that the speed, a tiny bit of time happens each time they hit each other and they reflect. So let's say they hit each other and they actually do reflect. One goes this way and one goes that way in the interaction. Well, if that takes a tiny bit of time, you could figure out that if the universe is getting more gravity, that the photon could have left in a field at a certain frequency, but as it's plowing into more gravity, it's having more of those interactions, which are slowing the light down. And slowing the light down means you're going to expand the frequency. So if I slow the light down, I'll expand the frequency. And that could be the explanation. No space created. It's just that the light itself has to travel through more interactions with the force. More of these little head-on collisions, and therefore its progress is slowed down in terms of getting through space, and that slowing down of its progress means that it'll be an expansion of the distance between each little bit of energy. So I'm just saying there's other explanations besides this. Space just happens to expand. Space just nothing makes more nothing, and then the nothing pushes the things away from each other without giving them velocity. I'm just saying that explanation sounds convenient. It doesn't sound right. It just sounds convenient. It's invisible manny. I don't think so. I think there's a real mechanical explanation, not some the universe just makes more space and things just happen to move away from each other but gain no momentum through the process. That doesn't make any sense to me as the probable right answer. That looks like the least probable right answer, and something like this looks like the more probable right answer. So if we thought of the universe, the point is, if you thought of the universe as a closed system, that is a bubble, I could just, sort of simply argue that the bubble functions, where any energy that goes out, photons, bounces off the outside as little bits of quanta, and does so at different locations because there's not a perfect circle of pressure or whatever. But the point is anything that's in stays in the bubble. It all just reflects inside the bubble. So if I make that simple conclusion, I could argue that yes, of course, the matter could have more energy in it, or the space can have more energy in it. And those two things could yin and yang with each other over time, and the universe could go between the two circumstances of small objects in big pressure and, big objects in little pressure. And the inverse would be, as the matter starts to contract again, the pressure starts to reduce. So the pressure inside versus the pressure outside constantly flips back and forth. But the two pressures, like I said, will be sort of not on the same curve. One curve will be different than the other curve of when they hit their maximums. Like exactly equally out of phase. As the object gets smaller, the outside universe goes through its change in pressure from being higher to being lower, and then vice versa. When the universe reaches the maximum expansion of the matter bits, the external pressure starts to reach its maximum and starts pushing it back into a small thing again. Anyway, so I have no objection to the idea that something's causing the change in the light frequency, the spectral frequencies especially. But I'm doubtful that the something is magical space being created as the photons travel. I just don't think that's... Look, you can even think inside of atoms what's happening. You know, the electron's here, it's in a specific location, you're injecting extra space, moving the electron to some new location. The new location changes the pressure gradient between the electron and proton, meaning the electron has to absorb more external pressure to push the electron back to the proper location, meaning there's more gravity created by the matter because it's absorbing more energy. The expansion is going to force more distance between the electron and the proton. The electron and proton have a comfortable distance, like magnets. They're going to want to equalize that pressure between the other electrons and the proton. And so obviously more energy is going to have to be absorbed, in the sense that something's going to interact with it sooner. There's going to be reflection that happens sooner than it would have. There's going to, and you're going to have to move the object. And moving the object means you're, changing all of these force equations. So you can't push a bunch of distance into the universe without it having a consequence on the pressure in the universe. So I just don't think it's the right answer, because I think it would screw up everything, fundamentally, to be injecting extra distance. Distance matters. It controls the entire function of charge is controlled by distance. You can't just make new distance without it having a consequence on everything else. So I'm not at all comfortable with the theory that new space just poofs into existence. I don't think so. How can you explain it alternatively to current standard model of cosmology? I don't even know what a standard model of cosmology is. Does that include quarks and neutrinos and all of that horseshit? Frankly, again, I don't know. How many times can I say it? There's really very little evidence. And you people want to draw all these hard and explicit conclusions, and you're expecting people to do it, and you're almost demanding it of science. Tell me. And they're really not questions that can be answered with any certainty at all. Are they? I mean, you want this yes or no answer? Big Bang, yes or no? I don't think it's the kind of question we can yes or no. I don't think we're in any position to yes or no. All you can do is speculate about functions. And I'm just saying there's a whole bunch of functions that have been thrown off the table for no good reason, because you people seem to want an ether theory or a wave theory or some other kind of crap. Poofing space theory. I don't know. What can I say? I'm not going to play that. I've sort of already stated, to me it's not interesting physics because there is so little evidence. Why would I bother, when there's really fun things to understand, like magnets? You want to give your brain a little bit of a teaser. Why don't you sit there and explain how, I turn the magnet this way, it attracts, I turn the magnet this way, it repels. Now that's an interesting question. Okay, that's somewhere you can get somewhere, because there's lots of experiments you can do. Lots of experiments that have been done. But understanding galaxies and distances and brightness and all that crap, and how much scattering the light goes through as it passes through billions and billions of light years of space. And this is in the context of you people can't even figure out that a gravity lens is exactly the opposite of a magnifying lens. I mean, you know, I don't know. What can I say? You all want to fall for it. You want, like I said, you want the whole story written based on just no evidence. You want the "How did it happen" book, and they can't tell you that. All right. Anyway, since Big Bang and expansion are closely related, it would be nice to hear your viewpoint on that one too. I don't know how the Big Bang is in any way related to expansion, frankly. I mean, the original story was the Big Bang. Okay, things gained real velocity and they were really moving away from each other. There was no notion of let's just inject fun space. Let's blow up the balloon. Okay, things don't actually have to move away from each other. We'll just make them move farther away from each other by not giving them momentum. It's this argument. They go this way. Okay, and somehow they gain momentum from this object because they went that way. Yeah, it doesn't make much sense. Not to have, I mean, if you expand the space, I'm just saying, if you move something further away, you have to account for that as movement. You can't just sit there and play this game that their positions just magically change. Yeah. Well, anyway. So anyway, the original Big Bang was just this idea that the universe, was an explosion, so and that it started from nothing and condensed out of the explosion, like a giant smoke ring or something. And that was, I frankly see this is more stuff where I think they jumped to a conclusion, and the background radiation, I could still argue, doesn't make any sense. You wouldn't see the background radiation. The radiation moves right past you in the explosion, right? All the material bits are moving much slower than the radiation bits, so why wouldn't the radiation have already gone right past me? I mean, it happens in nuclear bombs and other big bangs. They don't make universes. So anyway, the whole story doesn't make much sense to me, frankly. I'd like to hear your viewpoint on that one too. Let's see what else there is. You covered a lot of subjects yet, but maybe you could attack the, I don't know what that is, Limbrada cold dark matter model. Why would I waste my time on it? I mean, frankly, it's bad enough they invent space, then they invent special kinds of dark matter to fix problems. I mean, it's, sorry, it's just magic physics. It doesn't have anything to do with facts. Okay, which is our current cosmological model? Well, it might be yours, but really isn't mine. Frankly, I don't, look, there's simple things that I don't even think they account for in their model. They keep wanting to force galaxies to be solar systems. Solar systems have odd planets in odd locations doing little orbital things, right? And they want to turn galaxies into that. And so they use the same kind of dynamic, like, oh, we have to have this heavy thing in the center to make this happen. When they have an obvious thing happening with galaxies that is quite different than solar systems, right? You have this obvious thing where you don't need the crap in the center when you have two big things caught in each other's gravity. So the spiral arms have gravity as objects, and you could argue that they're just orbiting each other. They don't need a heavy thing in the middle to orbit around. So I mean, even simple things like that aren't even explained to people. The galaxies are fundamentally different than solar systems because galaxies have a ton of matter in the space. I mean, the galaxies got a ton of matter here and here and here and here. They don't necessarily even need to have a ton of matter here. So, whatever. I think their modeling is fundamentally flawed. I mean, it's sorry. Yeah, I don't buy it. just the fact that they're so different. Solar systems, the only thing they have in common is they're flat, right? Okay, so they have a plane, a preferential dimension in which they form. And that's all they have in common, really. So they're clearly formed in two fundamentally different ways in the same universe. Somehow the same universe is forcing matter to condense in two fundamentally different ways. And so I would sort of argue that, that's the trick. I don't think galaxies are condensing. I don't think galaxies are pulling matter in. I think they're doing what they've done forever and ever. I think they're pushing matter out, and then they push matter in. They push matter out, and they push matter in. I think that's all they do forever. But anyway, blah, 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 blah. Next. All right, superior mind. Pi is more a functional number. Yeah, you could argue that there should be some constancy to it, like, in other geometry, in square geometry. But again, circles create this, what's the real, what do you use for a word for that, tilt in a line? Well, anyway, you can always add more resolution and a circle larger and larger circle. And a circle larger and larger would be probably a better way to say that, right? Yes. That's the C. That's what I left out of my statement. I'm basically saying that obviously pi can't be resolved because all circles are a different size. And yeah, it's really the infinite circle, the infinitely big one. That's the one that obviously, how can there be a solution to the infinitely large circle built into the constant? Constant can't account for the infinitely big circle. Now, even if the infinitely big circle isn't even possible to make in the universe, it doesn't matter because the number can't do it. It can't find that what size is the biggest. It can't know that ahead of time. That there's this is as big as it can get. It can't know that. So the number essentially has to cover all circles, which is impossible to do with an explicit number. That would be the argument. All right. Most of the time we get away with 32-bit precision. I don't even know if you need that much, but yeah, frankly, sometimes 3 will be good enough, right? You don't even need the 1/4. So yeah, I don't know what to say. In which case we actually do use rational, consistent approximation. I think it's always an approximation. I think the number's never accurate. Like when they actually take it to all these places, the circle actually did stop at 146. It didn't need to go any further. Whatever. I don't know what the next numbers are, but didn't need to go any further. That was actually the correct answer. But you can't know that it was the correct answer because we can't actually measure the circle. But there was an actual number. You didn't need to do all those extra numbers. They were wrong. They're actually an error. Because you actually it did stop right here. And that was the end. All right, anyway. In which case simulation's looking good. I'm tempted to go back to mine and try boosting the size of the matter bits and increasing the density and amplify the bit effect. Yes, when you also have to get the tricky part is getting the perpendicular thing, where this happens. The bit goes in and it decides to go left or right or in or out. Okay, because those are the 4 choices. And coming up with the right understanding that what's really going to happen is it's really dependent on how much is hitting it. How much energy from this thing actually bent down, did this thing, and came and hit this object. So how much green energy is hitting from any one side is actually going to decide which way you go. And that creates the attraction. But like I said, a subtle complication, but it really has to do with the whole idea of the moving charge being different than the non-moving charge, and the movement is just a reflection of the force pushing the object, right? So which way the object is being forced to move will decide which way the force goes versus which way the momentum goes. And that's the tricky part. Eventually I'm going to be releasing the source code, but somebody requested it, but not yet. I mean, not until it's more complete. In fairness to the guy who wrote it and all of that crap, be nice to release a semi-finished product and then you can play with it. And it's the nice thing is it's all in JavaScript. Essentially, it's all HTML5, and it's really that part I like, really. And so, but yes, the key is the density. See, the trick is for the repulsion to work. It has to do with how much energy is actually trapped between two things at a distance, right? And what you're really doing is bringing them closer together, and the distance in this vibration gets higher and higher, as you get closer and closer. You end up with this trap that creates this repulsion. Well, the trick is if you don't have a dense enough force, you don't trap enough. And so you could end up with, not any energy in here trapped, which means you won't be able to tell you got closer. So the trick is to having enough density that you can guarantee you have a force bit in here to end up getting closer and closer and creating the repulsion. So probably what I'll have the guy writing this code do the next step would probably be just to slow it down. So you might have to run the simulation for 20 minutes, and then speed up the take video of it and just speed it up to get it up to natural speed. Therefore you can have a really dense amount of force. But anyway, the point, lots of little blah 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 to get this thing to start making, it's making atoms, so to speak. I want it to make nucleuses, and then I want it to hold electrons. But the subtlety, you got to understand, the subtlety is so subtle. Look at the real world. There's only 100 atoms that have the right shape, that stay together, that don't fall apart. Just 100 configurations, no more than that. You can't, whatever. You can make a few that last for seconds, but I just mean, and the durable ones, there maybe only 90 really, right? There's some that decay so quickly. So obviously the structure, the geometry, it's not like you can just throw stuff and the geometry just falls into place. It's obviously a very specific structure, and it's obviously created under very high pressure in suns. And so this atomic arrangement is the geometry is critical, and it has to be exactly right, or you're not going to make those 100 geometric shapes. So that's a real challenge. But getting somewhere close to something like is I'll be satisfied with something close and something like, anyway. I realized a silly flaw in my old math and a quick and easy optimization. I could try using S whatever and GPI whatever, computer something or other, to drastically speed up the simulation. Ideally, I'd like to get to a point where we see stable matter formations that match up with materials that actually exist. Yes, well, I just understand the challenge is it's really tricky because, like I said, the universe, working for billions of years, there's only 90 configurations that work. That's it. I'm sure it tries lots of others, and they all fall apart and fail. So it's not like this is the simplest thing to do. It is challenging. All right. But some of these things, some of these simulations, and the thing, I'm going to, request. The other guy did it, and I just don't know how. I'm very, very disturbed. There was a guy in Australia who was also working on simulation, and he had just finished an update where things were really working, and all of a sudden he just disappeared. He's just gone. It's been over a month, and he had a cold before he disappeared, and I just don't know what happened. I don't like things. I don't like shit like that. It's creepy. Yeah, that's what it is. It's creepy. Okay, so where was I? Yeah, the little bucket idea. Okay, because the bucket idea has something to do with an electron and whether or not it's just momentum bouncing around inside of it. And so it's an interior pressure fighting the external pressure, and that's its structure. But it's this whole idea of you put energy into a system that's frictionless. And the idea is that you put in the positive energy. That was the first step, was the positive. The negative reflection will happen while it's moving, right? You've given it momentum. The bucket moves. The whole bucket moves, right? Now it hits this backside, which you've made hit sooner because you moved it. Right? And so now what happens? Well, the bucket stops moving because now you've taken the 1 plus and you've added a minus. So now you have 0, right? But now you have the reflection back to the front, and the front is at this location, not where you reflected. It's a little ahead of that because it was moving the whole time the energy was going the backward way, right? And now you're going to hit the front again, and you're going to add the plus again. And then you're going to add the minus, and then you're going to get 0 again. So you're always just going from plus to 0, plus to 0, plus to 0. So this thing goes through space, just going, stopping, going, stopping, going, stopping. Theoretically. Now, they don't see, when conventional physics talks about momentum, they don't talk about this kind of effect. They don't really deal with the fact that a reflection can give momentum to both objects by this idea of an exchange, by the idea that this already has a reservoir of energy, and that it can have a piece going this way and a piece going this way, and that you could in fact exchange. You could let this piece go out and you could put this piece in. Those kinds of mechanisms aren't even discussed by physics. And clearly I think that's not Newtonian. Okay, that's not F equals ma. There's more happening there, but it's a different kind of rule. It's still conservational, but it's not the same as F equals ma. I mean, obviously doing this through space isn't F equals ma, because at any one point in time you're either moving or not moving. So you're not F equals ma-ing. Alright, let's see, where were you? I really still could use, okay. Ideally, I'd like to get to the point where we can see stable matter formations that match up with materials we actually exist, right? Okay, yeah, I would likewise like that. But it's going to be challenging. So it's Tesla, not. One misconception about Tesla was that he was trying to transmit electricity through the air. Well, the point is that I did make the point. I mean, this is a subtle argument, okay? His theory was that, here's the Earth, and that you could pump electricity into the ground, right? So he was thinking you could change ground potential, and then you could grab that change in the ground potential, you could suck it out in any location, just by building yourself a little tower and have a positive, and that somehow you could create potential between this bigger negative because you pumped negative in somewhere else. So I pump a bunch of negative in, and somehow I can just pull the negative out with my potential change, because I've increased the potential change. I've increased the voltage to 200,000 volts between this point in space and this point on the Earth. So whether you're saying he's trying to pump it into the ground, it still requires you to go through the atmosphere. So I'm just saying it really doesn't matter how you think about it. I mean, you're pumping it into the ground here and pulling it out here. You still got to create the circuit, all right, the complete circuit, to have your pump. it's always a complete circuit. So theoretically, you still have to go this way too. Because that's the only way it can work. Well, anyway, so this idea of just pulling it out of the ground is just, like I said, silly. You can't change ground potential, in any meaningful way. You could add you could put $1 billion of energy into the earth, but at any one point you can only pull out a penny. Right? That's all you could pull out because it mixes. So at any one point, all you're going to see is pennies on the surface of the earth. So somehow you'd have to go across the whole surface of the earth and collect all the pennies to get back your $1 billion. It was just such an impractically wooey notion, and it's just amazing that he invested so much time in something that you could just kind of understand that the voltage isn't going to stay at 200,000 volts of collectible money. It's going to be spread over the entire. It's like one piece of gold goes in, and you're going to say, I'm going to collect the gold here. You can't do that. You have to collect the little tiny grains of sand of gold across the entire earth. So anyway, electricity through the air, and it would be impossible and dangerous to people. It could be pulled off, however. He wasn't trying to transmit electricity through the air, just get to the point, but through a higher dimension. So there's no higher dimension of ether and any of that stuff. He knew there was just the ground. Okay, there's the ground and the atmosphere. That's all you have to work with. Whatever. So yes, he believed in an ether, but he didn't believe the ether was energy. Energy was something that traveled through the ether. So you still had to collect it in places where it could move, and it can only move through, like everybody knew, electricity only travels through a conductor. I mean, I think Tesla understood that. Okay, anyway. Fine, I accept your critique, but I'm still going to argue I don't think so. I think he just misunderstood that you can't unfortunately pull it out, because the earth is going to change whatever you put in into little micro pieces, and that you'll just never be able to collect the micro pieces back into one clump of energy. All right. Who is the cute dog in Piro's video stream? So this is kind of girly stuff that I just really don't have much use for. The point is, his old dog, his dog died, and I think he treated poor little dog like shit, and thinks it had a marvelous death, and I don't think it was so marvelous. And it's all a sad story, and pets is a bad idea anyway, and we ought to abolish the whole nonsense. But whatever, that's what the dog is. It's his dog who died. Now, he's had other dogs who died, no doubt, but he just, the one dog he cared to memorialize. So this, here it is, more chick shit. Uno, whatever this crap is. I mean, Faith, I've been telling you this for, 10 years? I don't do whatever this is. Whatever this gibberish crap is, this little fun symbol-y thingy, these emoji bullshitties, I don't do it. Okay, I can almost tolerate whatever this thing is. Very cute. The little butt symbol sideways. Okay, I can almost, alright, get it. Little hearty thing. But I just don't want to do this. It's not that I don't want to. I hate it. I hate foreign languages. I hate crap I can't understand. I hate it. It's annoying. Stop doing it, please. Thank you. Your animation inspired me to open a Blender to make you a little 3D physics splash video. Well, you really shouldn't put the link all the way down here. Anyway, very nice of you, but, I don't even like my current icon. it's nice that it has the 3 dimensions and all that kind of stuff, but it's got curved lines in it, and I'm really against curved lines now. So anything that's going to have anything to do with my physics has to recognize that, no, the elemental universe is all straight lines. There just aren't any curves. Curves emerge. They just don't have anything to do with the real function of the universe. No curved lines. So, although this is nice, it doesn't really reflect my point. Because this looks like a little wavy thing. Little happy balls bouncing around. No. See, there's just not enough straight line there. It just doesn't say 2 plus 2 either, right? Because they're all one color. So, it just, but it's very nice. The graphics are very nice, but it's just not what I want to say. So, close. Very nice. Text is just about perfect. Very good. But, I'll play it now and then, maybe. I'll have to save it. Yeah, remind me to do that. Where's my save button? It should be here. It's funny, it's not here. Download, it's not here. When I need it, it's not there. What the hell is that? Some kind of conspiracy or something? Anyway, it's probably hiding. No, it's not hiding. Interesting. Well, anyway, I'll do that for later use. Such. What the hell happened? I guess YouTube changed something. Stinkers. That is annoying. Try one more time. Yep, it's not there. Huh, okay. Anyway, I'll have to see what happened. Something got broken. Whoa, what the hell is that? Whoa, yeah, this was funny too. I wanted to play some of that. Because they started talking about quantum mechanics and the different interpretations. And she had no clue. I mean, I don't know all the interpretations. I don't know. Whatever. Is that physics? It's kind of funny. Silly people, running the world. Just really is depressing. Alright, anyway. Mucking around with the physics particle engine inside Blender. Still working on making the particles actually self-collide. Well, I don't even care if they do that. I just want them not to be doing curvy crap. Yeah. Then I'll drop the gravity and trap thousands of particles in a box and reduce their size, increasing their velocity, and try to replicate your animation in 3D. It takes a lot of GPU power to render, but it would be cool to see in 3D. Okay, yes, it would be nice. Thank you, but really, yeah. Well, I mean, I'll say thank you, but no guarantees. I'll say, oh, wonderful. I'm just saying. So some sort of crap. Sounds play. So it's some sort of BBC episode from BBC Radio, supposedly comedy program about quantum mechanics. Okay, well, I'll get to that some other time because I didn't get to it yet. I didn't go see what it was. And it tries to answer and explain a lot about the universe. And yes, well, good. I'll listen to it and see. You're the one to talk about rudeness, Grumps. Good see how you treated no joy in life. What did I do in terms of my treatment? Do I kick him in the face or something? I mean, if you disagree with somebody and say, well, you didn't really, you're not allowed to do that. I don't think what you said is very good. I don't think you type very good. There, now I've totally ruined you, right? You can't get on with your life in any way whatsoever because I pointed out how I don't agree that your typing skills are sufficient. You don't even have a space after the comma, for fuck's sake. Come on. Grow a ball. I mean, at least one. Try to really work on it. Water it every day. See if you can grow one single little ball. Alright, I think the hippies had a part to play in quantum mechanics. Well, it sort of was before the hippies, frankly. That would explain why it's like crazy LSD trip. Well, maybe it had something to do with the flappers, 1920, the Roaring Twenties. Maybe that's when they really started juicing the physics. Because everybody was just drunk and horny and shit. What next? The flower power particle. Yeah, so there's no point in even saying what's next, right? They have entanglement. I mean, where were they going to go now next? So they've done ESP particles now. I mean, they really have seance particles. Maybe they will actually create an actual, instead of an antiparticle, it was to be a demon particle. Yeah, demons. They'll even invent demons in their little religion. Okay. Hell yeah, it's Woody Harrelson destroying someone with bad Dunning-Kruger. Loved it. Thanks. I can't even express how, I'm just so pleased that I've pleased you. The whole point is to grow up in terms of having a real argument about real physics, not just this crap about, hey, he's fat. Just come on. All right, Clay Lady again. Exactly true. I don't know what that means. I have always wondered what they were talking about when they mentioned waves. It's obvious that waves always consist of some sort of element, in this case, subatomic particles. Makes total sense also about the curves. That's right, yes. No reason for anything to do curvy crap, right? That requires you to have a steering wheel and to be drunk and, all kinds of stuff. Makes total sense about this. Okay. Makes total sense also about the curves being side product formations that just show up because the particle radiation straight lines meet in different points of the coordinate system. I also know that the universe always comes from something that predates the Big Bang. Well, you know that, do you? Okay. Like I said, I don't have any confidence in Big Bang theory. Could be. Can't say it's out of the realm of possible, but I don't think it's anywhere near the realm of provable. So there is always something before something else. Well, what I'm arguing is maybe there's not. Maybe the whole thing just goes, maybe just pendulum swings forever and ever and ever and ever and maybe that's how it works. Anyway, so there is always something before something else. I don't know. If it's simple enough, it can just be simply simple forever. All right, nothing comes from nothing. Well, says you. I think nothing does come from nothing. I think nothings give birth to nothings all the time. It's just that they're nothings are nothing, so it doesn't, they don't take up any space. Unlike their nothing. Nothing can't take up any space because it's nothing. There's always a cause to an effect endlessly into eternity. Yeah, well, that's all I'm saying is that this whole eternity thing is just going to hurt your brain. So I'm arguing that eternity can be just eternity of simple process. Always was, always will be, but it's always simple process, and it just goes through a simple evolution. It gets smaller and then it gets bigger and it gets smaller and it gets bigger and it gets smaller and it gets bigger. It just doesn't do anything interesting beyond just doing that. Alright, Gary, I think you are a genius. Well, are you qualified to diagnose me? But anyway, we have to protect our geniuses. Whatever. Our useless. What does that even say? Oh, it's an eye. Okay. My eyes are bad today. I think a black hole will melt whatever, all this stuff into a compressed and condensed space where all atoms and subatomic particles change into condensed energy. It doesn't matter. the energy still can't be infinitely compressed, in my opinion. So there's no singularities. There's none of this horse shit. But no, I just, yeah, I guess I'm just, you want to believe it, it's okay. I just think there's no evidence of it. Where's the mega black hole? I mean, theoretically, creating these singularities mean, why wouldn't a very large singularity be created and the whole universe would just be sucked into it, and that'd be the end of this whole nonsense? I mean, there has to be some real physics here, not, magical infinity, things being in the same place at once, and, it's all kind of bullshit. You want to believe it, that's your business. I don't have any interest in that kind of shit. Don't be mean to your supporters. Well, I'm sorry. I don't have any obligation to be anything but honest. And so that's, I'll give my honest reactions to things. And, I'm not really going to exchange, I'm not going to compromise the integrity of the argument or the integrity of the subject because somebody's paying me or because somebody says nice things about me. Sorry. It just doesn't work that way. So if you say something stupid, I'm going to say, I think that's stupid. It's just the way it is. Sorry. It's the whole nature of this supporter stuff. What supports me is, there is enough oxygen to breathe and I have enough food to eat. That's, I guess I wouldn't sacrifice enough oxygen to breathe over a principle. But I just don't see any point in pretending, because you say some nice things that I should just pretend you don't say anything stupid. I can't do that. Don't really want to do that, frankly. And a new GIF is born. Oh yes, that's when I was imitating Captain Kirk and Brian Greene. Hilarious. Anyway, it was just so funny to watch. It's funny how you've been arguing with Pirro for over a decade. He's your own person. Okay, yeah, we already did this. Contrarying, following you from philosophy to physics. Well, whatever. Blah, blah, blah. Yeah, Pirro's an idiot. I know this isn't pertinent to the discussion, right? I think we already did all that. All right, so we'll move on to a little bit of... what's his face? Yeah, what's his face? Now we have to put up with commercials. What a downer. Well, maybe I'll take a little break then until I get rid of the commercials. Alright, should be back. So Sean Carroll, he's doing his biggest ideas in the universe, force, energy, action, and yes, it's it's really not about force, energy. He might be talking about action, but he's really not getting to the elements. What can we surmise to be the functions here? This distinction between force and matter. And that's, to me, the only way the argument should be phrased. We know there's stuff moving the speed of light, infinitesimally small stuff that causes magnets to move, that causes charges to move, that causes all the stuff that moves to move. And that should be the defining line, but instead he's making a relativity argument and all that kind of crap. So we're back to the old spaceship thing, and now we're going to talk about these rules that somehow Galileo established and then Einstein established, and it's just these silly, again, it's this idea that the same physics applies to big objects that applies to little objects, and I'm saying the little universe runs a little bit differently, that F equals ma emerges out of what the little universe does. It's not something the little universe does.
Over the radio, so they didn't give you any windows. You can't look outside in your rocket ship. These are the rules of the game. This is how thought experiments work. Sorry.
Right, so it's a thought experiment based on the conditions they establish as the rules of existence for all things in the universe. And again, I'd say the small universe is playing by different rules.
They ask you, the radio comes on and says, "Where are you?" But all of your instruments are down. You're stuck in the rocket ship. You can't see outside. You can't notice anything that's going on outside. Is there anything you can do to figure out where you are? No. The answer is...
Okay, so he says no when this is exactly Einstein's thought experiment. I mean, it's exactly why Einstein bent light. Okay, so this is why they say light is bent, and it's bent at twice as much. The gravity, it's bent twice as much by gravity. It's fundamental. This thought experiment is Einstein's thought experiment. Okay, so you move the ship, and theoretically, all right, with a velocity or an acceleration, either one will work. But the point is you have a light clock. You send light across the ship. The idea that Einstein's establishing is that light doesn't care about this. It doesn't care that you're moving this way. It doesn't care if you're moving this way with a flashlight. If I move this way with a flashlight, I don't make the photons move faster. I can't give them more momentum. And I can't move the flashlight this way and give the photons less momentum. I can't change their speed c at all. And I can't change their direction by doing this with the flashlight. I don't make photons that curve. They all come out straight. And the argument is that the spaceship, this other wall of the spaceship moves this way. Obviously, it will appear to somebody standing in here, hell, my beam of light hit the wrong spot. It hit down here. It was supposed to hit here. How come it hit down here? Well, it didn't hit down here. It actually hit exactly where it was supposed to, and with a straight line, you just moved the ship before the light got here. So the light left here. While it's traveling, the ship moves this way. The target moves, and it appears that the light hit the wrong place. It didn't hit the wrong place. It hit exactly the right place. The light didn't actually bend down and hit the wrong place. But Einstein's thought experiment is pretty much, I have to make it look like. So I have to make it look the same. So again, we're back to this relativity argument that is so stupid, where they're saying, I have two events that happen spontaneously, exactly the same time. And I'm going to play some game that if I'm closer to one than I am the other, it's fair for me to say this event happened first and this event happened second. It's not fair for me to say that. That would be me being stupid. I'm closer to this one. Of course, I got the information sooner. The wind hit me sooner. The smell, the whatever. I mean, you can do this with sound. You can do this with anything. Nobody's fooled by that, right? I mean, intelligent people know. Well, no, they're still spontaneously happening event. I mean, not spontaneous. Same time, simultaneous. They're still simultaneous events, and I can deduce that I might have a position that creates a bias. I might be able to see that this one's smaller and this one's bigger, so I know there's a distance difference. I'm not going to be confused. I'm not going to sit there and have an argument with this. These two people aren't going to sit there and actually argue and say, no, this one happened first. No, this one happened first. They're not going to be that stupid, are they? Not to recognize that, yes, their position in space is going to decide when they get a newspaper. How far you are from the newspaper delivery guy's house is going to decide how fast you get your newspaper. Gee, I had no idea. Of course it's going to matter. So why are we even having a conversation that this is true and this is true? Those things aren't true. There's no truth value to their bias. It has nothing to do with this actual universe. It has nothing to do with actually describing it. So why are these fake conditions? So he just made an absolute statement. All right, that's just totally wrong. There's no way to tell how fast you're going. Yeah, there is a way. I could use a magnet, okay? Because I know if I start going really fast, two magnets aren't going to stick to each other either. Because the force coming off the magnet is also moving the speed of light. And that force will also miss the other magnet, okay? Because the magnet's going to move its position. So these two magnets will not be able to interact with each other normally. They will not be able to attract and repel the way they would because they're not going to be in the same place anymore. One magnet's going to move while the force was produced in one place. The magnet's going to change its position by the time the force gets to it, and it's not going to be able to hit the other magnet. And that's just a fact. So this whole mush is just that mush, that there's no way to tell. Yeah, there is a way to tell. Obviously, we can't make a laser beam straight enough. If we could make a laser beam that was truly one photon and dead straight, one photon, and it didn't have any polarization problem, and it didn't have any divergence problem, diffraction problem. we could make a perfect aperture for it to come out of, that it didn't have any spread in it, then yeah, we could do the experiment. But it's still hard. Obviously, the distance has to be pretty great. You have to bounce it off a lot of mirrors. But if you had a really perfect photon, you might be able to do it. And you would be able to use the light clock to see exactly what your speed was. The illusion of deflection would be exactly proportional to your speed. So the faster you're going, the more the line would look crooked. But he says it. It's an emphatic thing he's saying is a truth of the universe, that what I just said isn't true. That the light clock won't work somehow. Somehow it's going to break. And even though Einstein said photons, are bent by gravity because of this bent line, he had to make photons traveling across the surface of the Earth look like that bent line. That's why he bent them on the Earth. So this theory that the photons jump to the future and end up going to the right location, is that what he's arguing? That the light clock actually doesn't create this straight line and doesn't go down the side of the ship as Einstein proposed? That somehow the light goes forward?
No, not without looking outside. There's no difference in things you can do in the rocket ship between being at one place in the universe and being at some other place in the universe.
Now, see, this is only true for drinking tea or writing on chalkboards, stuff that has, where we are being so imprecise that we won't be able to tell that the side of the ship, escaped the physics. That the time it took me to move the chalk to the board or something, whatever the thing is, when you're not going to see it. Because the universe is the one universe. The little tiny universe is where all the action is.
Universe. If you tried to do local physics experiments, measuring F equals ma and throwing baseballs around, there's no difference in the answers you would get no matter where you were located.
So again, it's not about throwing baseballs, though. Isn't that the point? Is recognizing that the force is the standard. The force doesn't care about momentum. It has its own photons. The energy is independent. It can't be changed. It can only be misdirected. The only thing you could change is which direction it's moving in. You can't change it in any way by this momentum nonsense, because the little bits are always interacting with little bits, and the little bits are always moving the speed of light. So for them, it's always the same universe, in a sense.
There is, in other words, no preferred position in space.
So that's their draconian. They make these statements, which I don't think they can make a logical argument saying that's true. Even if there is relativity, that there's no such thing as something going absolute zero and something going the speed of light. That everything is in that range somewhere. That everything has an explicit speed. That it actually has a real velocity in the universe. That is, if I was to shoot one photon through the universe, you have movement relative to that one photon. That you are actually moving closer or further away, so there is a straight line in the universe. There is a real points in the universe, and you are moving relative to those real points. They haven't proven that's not true in any way, and yet they're just establishing it as a fact that somehow that's not true. That your place in space is not a real place in space. They're essentially saying that. They're saying there is no place in space. That somehow placement is nothing. It doesn't mean anything. You're just relative to something else. And it's not true.
That is a feature of Newtonian mechanics. Likewise, if they asked you, well, how fast are you going? You might think you could do that. You could read the speedometer or whatever, but if you don't have any instruments, if you're not allowed to look outside, if you're just doing experiments and looking at things inside the rocket ship, you can't tell.
I mean, even the way he's saying this is kind of stupid. You have no instruments. What are instruments? Instruments do experiments. An altimeter is an experiment. Everything that measures they're experiments. I mean, how can you not call them experiments? Every instrument's an experiment. It's testing. Well, anyway, so this is just poorly stated.
How fast you're going either. I mean, fast with respect to what? If there's another rocket ship going right next to you, it might be moving at zero velocity, even though you're both moving at high velocity with respect to the Earth. With respect to that other rocket ship, you're stationary.
Right, but with respect to a single photon, I shoot through space in one direction. We will both have a relative position to that same thing, and that same thing will tell us where we are, just like the two things happening spontaneous. My position does not change the realities of other things' positions. Everything has real positions. I mean, this is just, in my opinion, this is just a religion, right? Because they really don't have evidence to back this up. They have no real reason to believe that position isn't solid, that I am a specific different distance in space between me and this chalk, and it's an absolute fact that it's occupying a certain geometric place in 3 dimensions, and I'm occupying a certain geometric space in 3 dimensions, and those are absolute positions in the 3 dimensions. It's just everything about this world screams that, and somehow they're saying, no, that's not real. Well, yeah, it is real. Distance is real. And that something right between us sees both of us at the right time, okay, at real time. And something closer to the chalk has a bias, and something closer to me would have a bias in measuring the two objects because the distance is different. Their instruments won't give them factual data. They'll give them an incorrect perception. But obviously, different instruments can detect that. Just as I pointed out that if I was between 2 explosions, I could see that one explosion was bigger than the other explosion, and therefore understand I was further away from one than the other.
So the moral of that is there's no preferred velocity in Newtonian physics.
So again, this nonsense. No preferred. Why would we even use the word preference? Why don't you just say absolute? He's saying there's no absolute position, there's no absolute velocity, no real velocity. Everybody has some kind of fake velocity, some sort of not in 3-dimensional space velocity. It's an incredibly extraordinary claim that is completely breaks everything about our common experience, and yet they believe it. Somehow it's the truth. Yet it can't make any sense to somebody who's doing logic.
Either. So by this point, you're thinking, all right, there's no preferred stuff in Newtonian physics, right? But if the person on the intercom said, on the radio, said, how fast are you accelerating? What if maybe you were accelerating, right? What if there was some rocket fuel going out and propelling you in one direction? Could you tell how fast you're accelerating? Sure, you're pushed downward. You're pushed in the direction opposite.
No, you're not. If you're merely too distant to sense, the instrument can't detect it. So again, if I make the spaceship big enough, the spaceship can be accelerating, and I have no idea that it's accelerating. If I can't see the walls of the spaceship changing in some dramatic way or something, I won't know the spaceship's accelerating until the floor hits me. So, I mean, this is just playing word games, right? I mean, like I said, it's the light clock will work. Certain instruments will give you certain information, and you have to just wonder whether or not it's completely accurate or not, or how biased that instrument will be in its detection, how correct it'll be. But there will be plenty of information gleaned, and like I say, you just put windows on these things, and this whole thought experiment just unravels into bullshit. Because the real universe is out there, and the real universe is doing a thing when you're moving, and it is moving relative to you and all that kind of crap. Because the real universe is in a static position, or the real universe is actually moving. It doesn't matter which one's moving, but something is moving relative to the other thing. Something actually. So if I send 2 twins into space, and one stays home, one twin leaves, there's an absolute truth to the fact that either the twins moving in the opposite direction of my velocity, and therefore we'll have an opposite experience of change, Or I'm the one, standing still. I'm the one that's actually still moving because the other twin, by leaving, eliminated their velocity. And so they're no longer moving. And they're the ones that are not going to age. And I'm the one that's going to age. There's an absolute truth to which one will age. One of them is going a real velocity, and one of them is going just an illusionary velocity. That's a fact. Their own thought experiment demands that it's a fact. That the twin scenario demands that it's a fact. One of them has actual real velocity. And either the twin increased its velocity by leaving, or the twin decreased its velocity by leaving. And that's a fact.
To the acceleration, because roughly speaking, you want to stay stationary, your inner rocket ship is pushed this way, so you feel that push going on you. So there is a preferred acceleration, namely zero acceleration.
So, this is such a silly, again, this preferred nonsense, as if the matter cares. There's either a force acting on you or no force acting on you. There's no preference. Nothing sits there and says, I prefer to stay here. Okay? No, it's either getting pushed equally from both sides or it's not. You either have a flame on the engine pushing, adding more energy in, pushing more force in, or you don't. But it has nothing to do with any preference.
You can tell whether you are accelerating or not.
Right, and how do you tell? Because the acceleration goes through you as pressure. It first pressurizes your feet, and then it pressurizes your legs, and then your knees, and then the other bones, and it goes right through your whole body as a pressure, as a change in the atomic structure. The electrons push against each other and create more energy, and they have to expand, and it migrates through you, and you can feel it happening. Your nerves sense the pressure.
And this state of not being accelerated, this is called an inertial trajectory, right? These are the trajectories for which momentum is conserved and kinetic energy is conserved.
So again, the true inertial condition is in absolute space. You have an absolute position in space, G5, like a battleship. Your peg is in a real place, and your peg has momentum in a real direction. Okay, and that's the fact. And the fact that it's a little hard for us to ascertain that without doing relative positions, without noticing where other objects are. And we can't be guaranteed those other objects are moving with us, are stopped, or are doing something. We don't know what they're doing. We can only see them in one moment of time and where they are. And we can figure out where we are relative to them. But that's it. That's all we have. So the fact that we have a lack of data doesn't mean there isn't a real inertial state. And the fact that I can share an inertial state, that is, I can share velocity with something else. We can both be standing on a trampoline. We both jump up. Well, so what? That doesn't mean we're not both moving. Okay, it doesn't mean that we don't have momentum in a direction because relative to each other nothing changes. The fact that relative to each other nothing changes does not mean we are in some bubble of reality. It just means that we're both going the same way. It physically means nothing. It changes no physics.
Conserved, etc. So there's a preferred class of trajectories in classical mechanics. If you want to think of it, if we draw a space-time diagram, right? So space over here, time over here. There's a trajectory where you start at some point and you're moving at constant velocity, namely 0. There you are. You don't know where you are, you don't know how fast you're moving, but that's an inertial trajectory. You're moving at some constant velocity. Here's another.
And again, the constant velocity relative to some other thing's position, which could be a complete lie because you don't know which way it's moving, and you are sharing some shared motion. So, but whatever. Won't bother getting into all this space-time crap. A completely unproven existence of an unproven medium. The only thing demonstrated by any kind of science is that clocks are broken by velocity. Their function degrades, and it degrades for each kind of clock. It breaks a different way, and it just happens that atomic clocks have a certain amount of consistency, so we can use decay rates to quantize, to qualify a rate of change, but it just doesn't mean anything. It just means that because there's a correlation between how fast you move an atom and how capable it is of decaying, can just be explained as a multitasking argument, that the more velocity you give it, the more you're changing its capacity to do its mechanical structural events, and so its events are delayed by equal to how much you're forcing it to do something else. So if you're dancing and I ask you to stop and drink a glass of water, you're not going to get as much dancing done. The usual analogy is, if you're dancing in one position as fast as you can, and then I ask you to move left, the process of moving left was going to slow down your capacity to dance as fast as you were. So anyway, enough said. And until the next time and such, and so forth and whatnot. But this is really very poor scientific rhetoric.